Okay, so today we are going to create a new Java program and we're going to talk about numbers and constants. So let's call this public class numbers and constants. Then we're going to have our matching curly braces. Now, one thing you may or may not have noticed is white space. I'll type that. White space. The Java compiler ignores white space. In other words, if I have a curly brace here, or here, or here, or here, or here, or here, or here, it doesn't really matter. For style, it's better to put it right after or give it a little space. It doesn't really matter which one. But white space is completely ignored by the actual compiler. So public static void main string args. At this point, we know about the integer. We have seen int, and we can call it num1 equals 4, and we can call it anything we really want. We can say num1 equals 5, whatever we want, and that integer will be a 32-bit integer. And what is an integer? What is an int? It is an integer, no decimal places. It also takes up, an int takes 32 bits. Now there's all sorts of different types of numbers. So there is a byte, B-Y-T-E, and that we'll say that's num2, and that equals 23. Okay. There's also short, and I'm going to call that num3 equals 55. And then there's a long, and we're going to say big, and equals, let's give it a really big number. There we go. The differences between these, and this is the order, we go byte and short, and then the int would be in here, so this would be our num4 and equals, say, a nice big number 2, but not as big as long. A byte takes up 8 bits. 8 bits. So it's really not very big. And then a short takes up 16 bits. And then an integer takes up, as we know, 32 bits. And then a long takes up 64 bits. I missed the 6. There we go. So what's the maximum number you can have? Well, it's not really that big. So I'm going to bring up a calculator. Let's see here. Where's my calculator? There we go. Have a nice handy-dandy calculator. There it is. And I'm going to change it to scientific mode. There. So on a byte, that's an 8-bit number. And these are all, these 4 data types are all integers. No decimal places. There we go. So, what can you do with 8 bits? Well, the answer is not a whole lot. 1 bit is to tell us if it's positive or negative, and the other 7 are as big as you can get. So that's going to be 2 to the 7, and that equals 128. Well, we need a place for 0, so this goes from negative 128 through 127. And that's as big as we can get. So for example, I'm going to system out println, and we'll do num2, compile that. Yes, I'd like to save it. And what did I call it? Just copy and paste. This is called numbers and constants. Put in the same place as I always do. Save, okay, and then run it. Okay, we got 23. Great. Well, can I make this 127? 127. Yeah, I can compile that. A byte can take up to 127. No problem. Can I make this onto 128? No. Incompatible types possible lossy conversion from int to byte. In other words, it's too big. 127 is as big as we can get. Well, if we go back to our calculator, what about a short? A short only has 16 bits, so 1 bit is used for the negative sign. So we have 2 to the 16 minus 1 is 15. All right, well, that's 32,768. Well, we have to have a place for a 0, so that's negative 32,000. Let's see, can I copy that? I think so. Negative 32,768 to positive 32,767. Ah, okay. While we're at it, we might as well keep going. How big can an integer be? An int. So byte short int. All right. So now we know it's 32 bits. 1 bit is used for its positive or negative. So we're going to say 2 to the 31. Oh, that's a really big number. So I'm going to put in some commas in there so you can get an idea. There we go, comma, comma. Put a negative sign in there. So 100, 1,000, million, billion. And then same thing, but I need a space for the 0. And there we go. In general, we are going to use an integer. Byte and short, they're so small. What's the purpose of them? In today's world, we really don't need them that much. We might use them on a mobile device that really needs to watch how much memory we use, but we're talking that's like 1970s kind of thing. We really don't care about bytes and shorts anymore. So we will completely ignore that. But I just wanted to make sure you knew all about everything. So there's byte and there's short, and we won't really be using them. Ints are great. We're going to use them pretty much for all the time. Except that, look, this. 100,000 million billion. You can only go to 2.1 billion. That's a big number, but the national debt is a lot bigger than that. So we can't even use an int for national debt. So let's use a long. Well, how big can we get for a long? Clear that out. Well, it's 64 bits. 1 bit tells us if it's negative or positive, so that's 2 to the 63 bits. Whoa, that's a big number. What is it even going to show up like? Wow, 9.2 times 10 to the 18th. Well, that's a really big number. And it would be negative all the way to same thing, -1. And the -1 is so that we have a space for the 0. So longs are really big. They're really long. That's the whole point of a long. So these 4 data types, byte, short, int, and long, are all integers. They have no decimal places. In fact, let's try and change. This should compile all nicely. Good. So what about, we're going to say num4 equals 3.14159. That's just a small approximation of pi. If I do that, it compiles. No, it doesn't compile. Incompatible types, possible lossy conversion from double to int. In other words, if this were to do its thing, it would chop off the decimal place completely. So what do I need to do? Well, the 2 floating point data types. Floating point means that where this period or point is can literally float. So it could be 13.4 or it could be 0. And a whole bunch of numbers after that. There's 2 different types, and there's the float, and I'll call this one num5, and that'll work. It actually doesn't like us because it thinks it's a double, so I'll put an F here. Yay, that works. And then there's the double, and I'll do num6 equals 3.14159. The reason we have to put an F here is this is a literal. So what's a literal? A literal is a number. like 3, 4, and our 3.14159. The default numbers, default numbers or default data types are int and double. So float, what is this? This is a 32-bit float, and this is a 64-bit float. By default, that is going to be a double. By default, without the f, it would be a double. By putting a capital F or a lowercase f, it doesn't matter, then it says, okay, I really do want to put this floating point literal into a float. In this class, the only two we care about are the int and the double. You should know about the others, especially if you are going to continue on beyond this class. But those are the data types for numbers. So there's 6 data types that Java has, but the ones we are going to be using pretty much exclusively after this video are ints and doubles. Just so you know, this might cause a problem in the future. If I have a long, and I want to have long, I'm going to say, more than 2, let's see, is that billion? 100,000 million billion. Yes, more than 2 billion. And I'm going to say equals, look at the maximum number we can have here for an integer. We're going to put that there. This will be problematic for a couple of reasons. Well, actually just one reason. Can you guess what will happen? It will, I'll hit compile and, uh-oh, look, it doesn't like any of those commas. I wish it was okay with those commas. It would make life easier, but it's not easy. So we compile it, everything's good. So I can obviously put this big number, that's the biggest integer you can possibly have for an int, but not for a long. I mean, we can have 18 zeros. Oh yeah, but that's a lot more than here. So what happens if I just make this 1 more than the maximum of integer? Uh-oh, error number too large. Well, wait a minute. This is a long, and I'm saying I want this number put in a long. So what's the big deal? The big deal is Java's not as smart as it should be, really. It says this is an integer, and then it has to put this in a temporary spot before it puts it in here while it's compiling, and it says, whoa! We can't do that. So if we want to actually use a bigger number than the maximum size integer, we have to put an L. Yay! And now I can put really big numbers in here. 0, 0, 0, 0. That's a really big number, and it has no problem. We can also put a lowercase l. It doesn't really care, but I would stay away from that lowercase l because look, that's an L and that's a 1. Do they look almost identical? To me, they are almost identical. The little top part of that L here is completely straight. Well, this little top part kind of curves. So to avoid confusion, use a capital L. All right. So there's one more thing we need to talk about before the end of this video, and that is a constant. What is a constant variable? One that does not change. So how do you make a constant in Java? Well, it's actually really easy. All you do is type final. So I'm going to say final pi equals 3.14159. All right. Final pi. Is that going to work? Oh, no. It has no idea what the data type is. What's the data type? We know it's a number, so it has to be one of these. We know it has to have double precision, or a floating point value, so it has a decimal, so it has to be a float or double. And since we don't care about floats in this class, it's a double. All right. So in this class, easiest way is, should it be an int or should it be a double? If it does decimal places, it's a double. If it doesn't have decimal places, make it an int. So we're good to go. All right. Well, with this double, we're going to say num6 equals 55.32. Hey, that works great. But with a constant, with the keyword final, we can't do that. So pi equals 2. Uh-oh. Cannot assign a value to a final variable pi. Well, maybe I need to put a decimal place. Actually, I don't, but it's a good guess. Still, it won't work. When we have final, it means you cannot change it. Why would you want to create something that's a variable that does not vary? Well, a variable is nothing more than a memory address. So when we create a constant, what we're saying is, I want a variable address with some data that cannot be changed. Well, do you really want somebody changing pi? No, you don't. One final note about the constants is the style, the style of constants is all caps. Notice the P and the I are both capitalized. That's for the purpose of other people knowing exactly why, or exactly that this is a constant and it cannot change. It's style, so this could be all lowercase. It doesn't really matter. But so that other people, and even yourself, know, we capitalize pi so with all caps because that's the way the style is. All right, that's it.